Alrighty, so today we're going to be looking at polynomial division. Now the point of polynomial division is it's going to actually help us factorize where we can't factorize as easily as in the previous lesson. So this is going to be a little bit of a helpful thing. This lesson, we just want to focus on the division part of it. Can we do that? Next lesson, we're going to look at why this is useful, but for the moment, the only thing we're interested in, can we actually divide by a polynomial? So let's imagine we have something like x to the 3 minus 2x squared plus 5x minus 6. And let's say we wanted to divide it by x minus 2. We might look at that and go, well, how exactly do we do that? Well, actually I'm going to make it x minus 3. Well, we do it using what's called long division. So long division you would have done before when we used to do in primary school. And before we go ahead and do long division, let's practice long division. So let's imagine I have the number 728 and I want to divide it by 7. Alrighty. So the first thing to go is, how many times does 7 go into 7? Well, 7 goes into 7 once, remainder 28. How many times does 7 go into 28? Oh, so 2. It does not go into 2. So then we include the 8. How many times does 7 go into 28? It goes into 28 4 times, leaving 0 remainder. Therefore, 728 divided by 7 is equal to 104 and 0 sevenths. Basically, remainder 0. Alright, let's do one where there is actually a remainder. So instead of that, let's try something a little bit more monstrous. Let's look at 2015. Okay, let's try it. 7 can't go into 2. 7 can go into 20. 7 can go into 20 twice, which would give us 14. 14 off 20 leaves us with 6. 7 can't go into 6, but 7 can go into 61. 7 can go into 61. 56. That's times 8, so it can go in. So it can go in 8 times. Remainder 5. Bring the 5 down. 7 can't go into 5, but it can go into 55, and it can go into 55 times. It can get up to 49 is the closest that it can get. So that's 7 times, and that's going to be remainder 6. So in this particular case, 2015 divided by 7 is equal to 287 and 6 sevenths. Because that's what the remainder means. It's the bit that goes on the fraction. It's the incomplete part. Okay? So that's just division. That's that's regular long division. Let's look at polynomial division and see how it differs and looks the same. So the first thing is, how do I make x look like x to the 3? What do I multiply it by? Well, I multiply it by x squared. If I do that, I get x to the 3 minus 3x squared. Okay, why is that useful? Well, it tells me how to cancel this out, how to get rid of the first term. Because when I do this, I always want to get rid of one term at a time. So, x squared is my divisor. It's the thing I'm multiplying it by. So it goes up the top. I've expanded out that. And now what I'm going to do is I'm going to subtract this off x minus 2x squared. X to the 3 minus x to the 3 is 0x to the 3. That's the whole point. That's why I chose x squared, to get rid of the x to the 3. Minus 2x squared minus 3x squared. Well, minus 2x minus minus, well, it's minus 2x plus 3x, which is 1x squared. Now, we're also going to bring down the plus 5x from above. That's just going to come down. How do I make x look like x squared? Well, what do I multiply it by? I multiply it by x. And if I expand out, well, let me write it in the right spot. If I expand that out, I get x squared minus 3x. And since x was my divider, I'm going to put plus x up the top. Now here, I'm going to go x squared minus x squared, 0, that's the whole point. 5x minus 3x, well, that's actually going to be 8x. Bring the minus 6 down, minus 6. Now, how do I make x look like 8x? Well, I'm going to multiply it by 8. The divisor is 8, so I'm going to put the 8 up here. Expand out the brackets, I get 8x minus 24. And now I'm going to subtract this, so I get 8x minus 8x, 0, minus 6 minus 24, which is plus 24, is going to be plus 18. Okay, so like what I did over here, I'm going to do the same thing. Therefore, when I do my division, x to the 3 minus 2x squared plus 5x minus 6 when divided by x minus 3 is equal to my whole part, x squared plus x plus 8x, plus the remainder. Now the remainder is 18 on x minus 3. That was the remainder. That's what I was dividing by, and that was my remainder. So this was my whole part, there's my remainder. So that is polynomial division. It's quite tricky, takes a few steps to get right, but it certainly can be done. Alternatively, here's another way of looking at it. An alternative way of looking at it. Rather than thinking of dividing, well, this is a factor. And if I put the factor out the front, there's the remainder. Hence, this is going to be very useful for turning cubics into quadratics. It just depends on what you divide by. Alrighty, I'll see you in the next one. Bye-bye.